And welcome back to Lesson 3 in this three-part series on simulation modeling for lean process design. I'm Richard Rahn, and thank you so much for your comments. And there's this place on this page where you can continue to add them, and we'll respond to them as well. So let's review quickly what we've covered in Lesson 1 and Lesson 2. You can, if you haven't viewed these, by the way, you can view those on this page. You might want to do that first. If you haven't viewed them, just go ahead and click on that and watch those first. There's a lot of good background here that we won't be repeating in this lesson, but let's just summarize what we did in Lesson 1 and 2. So in the first lesson, it was really trying to answer the question why. Why is simulation modeling so important? And especially important for this kind of domain that we're talking about, which is the world of mixed model line design or multi-product line design, where you have this thing called variability that's very hard to understand without using some kind of model or simulation. So in a static design, which is something that's important, something you do need to do, in a static design you're looking at products, processes, times, standard times, a relationship of the processes, demand, volumes, etc. And there are calculations that we do in terms of resources required and this thing called takt time. But it's all done in a spreadsheet environment typically, and it's static. It doesn't test the performance of the system in the face of variability. So what kind of variability am I referring to? Well, several types. One is just human variability. People are not robots, and sometimes they work a little faster and a little slower. So how does that impact your line performance is a good question. Next one is the inherent variability of a mixed model line, where some products are harder and some are easier. And so when you mix those on the same line, how is this going to affect your line performance? Again, good question, right? And almost impossible to understand just in your head. And then you have other kinds of variables like changes in mix and volume. The customer wants what they want. We're going to design the line for an assumption or a forecast of mix and volume, but when that day comes to build products, we're going to build what they want to buy. And that's probably going to be different from the original mix and volume we used to design the line. So all those kind of challenges are things that are very difficult to understand just in your head. Even with a lot of experience, you can try to anticipate some of these things without actually using advanced tools, but still you're never going to know for sure how that line's going to perform until you get into the real world and you actually start building products. Now, unfortunately, waiting until you have a line in place and you start debugging it or fine-tuning it in the real world is the worst possible time, because now you're potentially affecting customer orders, for one thing. Number two, it's the most expensive time to actually make changes because you've actually put the physical line into place. So we'd like to avoid having to do that, and the way to avoid that is to build a model of your potential value stream or line or process. All right, so that's it in a nutshell. So I hope you're convinced right now that this is important and something we need to do if we can. And so that was the essence of Lesson 1 in a nutshell. Now Lesson 2, we talked about the what. So if we're convinced that this is something important, what's involved? How do we actually apply this, or what are the steps to actually developing a simulation model? And so we went through the prerequisites. You can really think of the what as a three-phase process. First of all, you have to have data. So the data collection piece of it, good news here is that if you've gone through the mixed model line design process as we teach it, you're pretty much 95% of the way there. Not 100% because there are some issues related to variability that you're not capturing in a static model, but pretty much you're there. You have the data you need. Products, processes, work time, demand, sequencing, all those things you need to have, and you will, if you've gone through the static line design process. In the middle part of this what, you have this whole challenge of creating a model, right? Building the model. And there's software involved, and there is certainly the skill involved in actually creating this simulation or model of a physical system. And that's no minor detail. So in terms of the technical challenge, I think this is the toughest one. You need to have the software, you need to know how to use it, and you need to have typically some higher level of computer skills. Not just learning how to use an application, but you need to have programming skills. Because as soon as your system design gets beyond a certain level of simplicity, and it will, guaranteed it will, then you're into the realm of having to create macros or code to get this model to reflect reality. So that's the middle part of it. And in lesson 2, you actually saw a model that we built, or that I built and shared with you, using an Excel-based simulation tool. So it wasn't very complicated, but I think that gave you a good feeling for what's involved with the data, building the model, and then running it. And then the third step of this process, the simulation modeling process, is, okay, once we've run the model, we have a ton of output of results. And your main job as a super user of simulation is to be able to interpret those results and use those results to improve the system. That's the main point there. Make improvements to throughput, make improvements to utilization, to productivity, etc. That's really the main goal. If you don't do that, then basically everything that came before it is kind of a waste of time. But we're using this to improve the process. That's the main point. Without having to build the physical system itself. Right? Without having to actually build the line and then test it later. So therein lies this confusion about the word Kaizen. You may have heard this word Kaizen, Japanese word, continuous improvement. But really what we're talking about with Kaizen is fine-tuning, not major redesigns of a line that wasn't designed right the first time. And so that's what we're hoping to avoid, is the need for excessive Kaizen after the line is in place, although there are always opportunities to improve, hopefully in smaller ways. So that takes us up to lesson 3. And again, if you haven't seen lesson 1 and 2, well worth your time, just click on the links on this page and you can watch those. Now let's get into the purpose of this lesson 3. We're going to talk about the how. So assuming you're sold on this idea of simulation, excited about it, and you have some sense now of what's involved, now we come down to where the rubber meets the road. How do we actually do this and become a simulation super user or a simulation modeler beyond that? So let's talk about the steps. And before I get into the steps, let me share with you a little bit about my background. So how I got into this. When I left my simulation company, I was a full-time lean consultant from, say, 1994 to around the year 2000. I was convinced at the end of that period that simulation was going to be necessary because we had successes, we had lesser successes, we had a few, I don't want to call them failures exactly, but projects that could have gone a lot better if we had been able to model the design ahead of time. And of course, in those days we had no such capability. And so when I left my original company that I started with doing lean consulting, I realized simulation was going to be important, and I joined a simulation company in San Diego, California called the Quran Consulting Group. And they were some of the best simulationists around. They were the pro model representatives for the West Coast of the US, and they'd done projects with all the big boys, big simulation projects. A lot of them were PhDs in industrial engineering. So I thought, this is great, I'm going to be a simulation expert too. And what I learned pretty quickly was that, boy, becoming really good at not only understanding results or using simulation, but actually developing these models, especially large, complex ones, was going to be a career change for me, away from lean and more into computer programming and that whole arena. And I didn't really want to make that drastic a change, so my relationship with simulation changed a little bit, and maybe this is somewhat similar to what we're encouraging you to think of, becoming a simulation super user, where you can be a valued partner in a simulation effort, but you may not have all the skills required to build that model in the middle. So I spent 2 years with them and I left. Went back to the world of lean consulting, but with a pretty good feel for what was required with simulation and looking for opportunities to use it. So let's roll the camera forward until just a few years ago. We got a proposal with a large company, this is a Fortune 100 company, on a project, line design project, manufacturing, and they wanted to include simulation in there. And they had their own department. This is a pretty big company, but that department was swamped with other things, didn't have time to work on this one. So they said, well, find resources to partner with us on the simulation piece of this project. I said, fine, I know just where to look. So I went back to the Quran Consulting Group and proposed this to them, and they said, of course, this sounds good. And by the way, they said, we have this idea. We've been working, we meaning Jalal Kaplan, who is the VP of that company. Now he has his own group, the Kaplan Business Group. And Jalal said, hey, you know, I've been working on an Excel version of a simulation tool. Now we could propose to this customer that we use ProModel, or there are literally dozens of other software packages to do this, but let's try, because this seems to be a really good fit, let's try using this Excel-based model. And the advantages are severalfold. Number one, it's going to be really easier to develop these models because it was designed for that kind of environment, kind of an assembly line environment. So it's really going to cut the development time way down. Second thing is the customer doesn't have to buy ProModel or some other software that they don't have, or on the other hand, we don't have to learn some simulation software that we don't know. And everyone involved, them and us, are already really familiar with Excel. Right? So entering the data into Excel environment is something that everyone is pretty much comfortable with. So we went back to the customer, we proposed this approach, and they said, sure, okay, sounds good. And so we did it, and it was a success. Changes were made to the design based on the output of the simulation. We spent days with the team running experiments, trying different things. So it was really very valuable. And at the end of the day, tens or hundreds of millions of dollars of product are being produced on this line that was put in place, so success. So then my thought was, where do we go from here? And I went back to Jalal and I said, well, what are you going to do with this? And he said, well, I'm in sort of a dilemma because I don't want to start a software company. I don't want to sell this, mainly because I don't want to be responsible for development, software support, all the issues that come with having a software company, because I'm already busy and I like what I'm doing. Jalal Kaplan, by the way, is a PhD in industrial engineering, so Dr. Kaplan. He had lots of other things to work on and didn't want to make this, again, a career change for him. So we just kind of put it on ice until about 6 months ago when I reapproached him because this was bothering me. We had this great, exciting tool that was not doing anyone any good. And I went back and I said, look, why don't we take a different approach to this? Let's not start a software company, but let's develop a workshop to really train super users, train people, not necessarily in all the details of model building, but certainly the data piece of it and the interpretation piece of it, and then give them this tool, this Excel tool, as a hands-on learning tool for the workshop. Treat it as a learning tool rather than a commercial product. And he said, okay, well that sounds interesting, that sounds good. So we discussed some more and eventually came to an agreement, and so that's the road that we're going down. So that is the kind of the backstory in terms of being a super user and the software that we're contemplating using. So I'm giving you a little bit of an advanced warning here. But let's talk about what you need to become a super user of simulation modeling. So let's take it step by step. So first of all, you need to get educated. If you're not already familiar with simulation theory, the benefits, kind of how it works, the basic logic, then you need to achieve that level of education first. So here are a couple choices for that. If you are so inclined, you can read a book. So here's the book that we use, that we recommend, that we like. It's called Simulation, the Practice of Model Development and Use. The author is Stuart Robinson, and you can buy this on Amazon.com. So this is not an easy read, but it's not that hard either. Somewhere in between, moderately difficult read, but it includes things like benefits, how does simulation work, how do you interpret data, all the things that you would really want to know, not as a programmer or as a model developer, but as a super user. So that's a great start. That's an option. Now, it is hard, I'm sure you can appreciate, to just read a book because it requires a lot of self-discipline. There's no one to ask questions to. You may not understand it. There's no way to have dialogue. So another option is to go to a workshop. And again, I'm paving the ground here for an announcement pretty soon here, but get educated, go to a class basically that will go through the same material, but with a chance to discuss with the trainer and discuss with your fellow students and do hands-on work, all of the things you can't really get from just buying a book, no matter how good that book is. But anyways, phase one, get educated. Phase two, we're talking about software here. So software is going to be needed, right? If you want to do this, and there are dozens and dozens of choices, lots of different products. And we're not selling any of them, but we have worked with some of them. So I'll just mention a few that we are familiar with that we like. But really, that's going to be up to you to research. The ones that we've actually used and like include Simulate. That's Simule and then the number 8. Simulate.com, I think, is the website. That's pretty good, pretty user-friendly, very graphical, kind of drag and drop environment. So that might be a good one to start. We've actually sat down with the Simulate people and talked about what we're doing. And so we're happy to mention them. Another one is called iGraphics. iGraphics is a graphing, flowcharting software program, but the more advanced versions of this product, iGraphics, have simulation capabilities. So basically you create a flowchart and then you lay the simulation logic on top of that. There's another one called ProModel. Now ProModel is one of the big simulation companies, been around for a long time, but they have a more user-friendly version of their simulation engine that integrates into Visio, Microsoft Visio, which again is a flowcharting program, and then you add on top of it the simulation aspects. And there are a bunch of others that I haven't used. For example, there's one, FlexSim is getting a lot of good press, 3D simulation, but literally just do a Google search on simulation software and you'll have no lack of opportunities. But one way or another, you need to have some kind of tool, some kind of software tool that you can use, because this is not something you do by hand, or it's not something you do with Legos. So that's something you're going to have to figure out. Now, many of you that work for larger companies, maybe that's out of your hands. The company already has a standard, which is good, right? You can take advantage of that, maybe take advantage of some training on that. And most of these software companies also have training on how to use their software available in the form of online training or even live workshops sometime. And then the third part of being a super user is, and this is probably the most important, you have to have some experience. So you have to do it. Actually work with data and work with models and actually improve processes and get some experience doing that. And there are two ways to do that. One is in a classroom where you have kind of like provided classroom type examples, and there's certainly value in doing that to get started. Because it's more predictable, you can get feedback from instructors and learn how this whole process works from start to finish. But then at some point you're going to have to get out into your own company, your own factory, your own processes, and start building models and start doing things. So how long would it take to get up to a high level or a satisfactory level of expertise? Not that long. Probably all of you watching this are pretty sharp. But it's going to take a few projects under your belt to really get a feel for what's required, what data do you need, and also what kind of questions do you need to ask. What you're going to find if you're a lean professional is that now you're asking questions that are a little more deep than maybe you were asking before. Because if you don't ask the right questions when you're building a simulation model, the model's not going to reflect reality. One of the things I appreciated a lot working with the pros on simulation is they knew the types of questions to ask, especially related to variability, that we typically weren't asking in a static lean environment, weren't used to asking. So that was a great learning experience too. So those are the three steps. Now let me cut to the chase here. An opportunity that I've alluded to or actually stated a couple times already. But we've taken this Excel-based software, we've negotiated with the author of it, and we've developed a 3-day simulation super user class, if you want to call it that, Introduction to Simulation. And the beauty of this, the exciting thing, in fact, this is one of the most exciting workshops we put together in maybe forever, any time, is that we're including the software with the class. So picture this, you go into the workshop, you're going to have a laptop. You're going to have a version of Excel. Now, because this is Excel, there's no software installation. I know that a lot of you have issues with installing software on your company laptops. You won't have that here because there's no installation. It's just an Excel file. But the idea is to spend 3 full days with myself, with the Leonardo Group team, and also with Dr. Jalal Kaplan. He's going to be there going over the whole process of understanding the theory of simulation modeling, getting right away, very quickly thereafter, getting your hands on the keyboard, building simple models, building more complex models, and then really learning how to look at this output, which can be voluminous, and understanding how you use simulation output to improve a process. So really, by the time you go back to your company, the vision here is that you haven't just been exposed to a bunch of ideas. You've gotten some hard hands-on experience with model building. And by the way, this will apply to any software package that your company may have. But you were able in this class to use the tool, use the simulation engine and build models and interpret results. So you're going to be going back to your company with a lot more hands-on experience than you normally would for a workshop of this type. So we're really very excited about it. This is coming up in June. So I think I'll leave it at that. I hope we gave you a good overview of what's required and then how to get started and how to do this. On the next video, what we're going to do is give you an opportunity to register for this workshop. So you'll be getting this in a couple days. And we'll tell you more about it in that video. So stay tuned. By the way, stay tuned because we don't have that many seats available at this class. It's a relatively small conference center. So once we open up registration, it could fill up. So if this is something you're interested in, keep your eye out for this next email you're going to get in a few days and take a look at what we're suggesting here, give you a lot more detail on the workshop and see if this is something that's going to be of interest to you. But for now, I'll leave you at that. Thanks a lot, and we'll see you later.